Hello everyone. The title of this video is Recognize the Graph of a Quadratic Function. Alright. Every exercise I'm going to do in this video is taken directly from a free online textbook at openstax.org, and it's their Intermediate Algebra 2nd edition text. I'm in section 9.6, titled Graph Quadratic Functions Using Properties. I'll be working under the heading, recognize the graph of a quadratic function. And I'm only going to be working on the even numbered exercises. So 230, 232, 234, and 236. Those are the exercises that don't have solutions in the text. The odd numbered ones do have solutions. You can just click on the links. I will also have timestamps for each of these examples in the description of the video. You'll see example 1 timestamp, that'll be for number 230. Example 2 will be for number 232. Example 3 for 234, and example 4 for 236. I also request that when I bring up a new question or a new part of a question, that you pause the video and try to do it yourself first before watching me do it and comparing. Because if you're just watching me do these things, these questions without practicing yourself, chances are you're not learning all that much. Great. Alright, so first question, number 230. Now in these first couple exercises I'm going to do, the instructions are simply graph the functions by plotting points. And I've got this written out. So example 1, which is again exercise 230 from the text. Just graph the function by plotting points. So I have f of x equals x squared minus 3. Hopefully you recall how function notation works, right? The function is called f. In parentheses we have our input variable, right? X is the input, and then f of x is the output, and on the other side is how the output is calculated. Right? You take the input x and square it, and then subtract 3. Alright, so I'm going to make a little table. Right, we're going to find ordered pairs that satisfy this equation. And then over here I'll make a very rough hand drawing, a hand sketch on the XY coordinate plane. And then I'll show you a better drawing on a free online graphing calculator at desmos.com. Alright, so just for these in this video, I'm going to put in some standard points here. I'll go from -3 to +3. So I'll plug in -3 for x, plug in -2 for x, -1, 0, 1, 2, and 3. Right? And then hopefully after plotting 7 points, I'll see enough of a pattern forming to be able to draw the complete graph. Right, to fill in all the other solutions to this equation. Alright, so plugging in -3, f of -3, so -3 squared is 9. 9 minus 3 is 6. Alright, so the ordered pair -3, comma 6, right? Input -3, output 6. I'll plot that on the coordinate plane. So over here I'm making a very, very rough XY coordinate plane here, x-axis. Now you could call this the y-axis or the f-axis. Right. And you already see it's not perfect. I'm not using a ruler or anything. So input -3, so on the x-axis I go to -3 on the x. Output +6, +6 on the vertical axis. And I'm trying my best to keep things evenly spaced. Right, and then we'll plot that point. And I'll do it in red. So -3 input, 6 output. So about here on my drawing. So there's the ordered pair, -3, comma 6. An input of -2 will yield an output of 1, right? -2 squared is +4, -3 is 1. So input -2, output +1. There's another point. And this is just like graphing, any other equation, right, with two variables. You find ordered pairs, right, for those variables, pairs of numbers that can replace those variables to make a true statement, and then plot those ordered pairs on the coordinate plane. Input -1, output -2, right? -1 squared would be +1. 1 minus 3 is -2. Right? So input -1, output -2, right? So I go to -2 on the vertical axis. So -1, -2, there's that point. Now it looks like they form a straight line, but they don't. You're going to see that coming up in the next few points. So input 0, right? 0 squared is 0, minus 3 is -3. Right? So input 0, output -3. So there, that's on the y-axis right now. Now you're going to see it start turning a little more. Not going to be a straight line, right? These points. Then input 1, 1 squared is 1, minus 3 is -2 again. And so input 1, output -2. So definitely not a straight line. All these points, right? There you go. So it's actually going to make what's called a parabola. You may have heard that word before. Input 2, right? 2 squared is 4, 4 minus 3 is 1. Right? So input 2, output +1. So 2, 1, there's that point. And then input 3, 3 squared is 9, 9 minus 3 is 6, right? So input 3, output 6. And this isn't the greatest drawing in the world, but right. And then hopefully after a bunch of these, now you can plug in, you don't have to plug in integers. You can plug in fractions, 1/2, 2/3, 3/5. You can plug in other real numbers, the square root of 2. But hopefully after enough points you'll see a pattern forming. Right. Looks like the graph is doing this, just connecting the dots here. Making a little make it curvy at the bottom. All right, these parabolas are not pointy. Right, they're curvy. And curve, right, curve, and then it looks like if I go this way, if I plugged in 4 and 5 and 6, the outputs would get larger and larger. So I'm just going to indicate that with an arrow after that point. And the same thing goes to the left. If I plugged in -4, -5, -6, the outputs would get larger and larger. Right, so I'll indicate that with an arrow as well. And like I said, this kind of U-shaped graph, this curl like this is called a parabola. Right, and a parabola is the graph of what's called a quadratic function. The graph of a quadratic function. All right, and a quadratic function looks like the following: f of x or y equals, and then some quadratic polynomial. A times x squared plus b times x to the first plus c. Right. So this is important. You should know this, right? So they sometimes this is referred to as the standard form or general form for a quadratic function. Y equals ax squared plus bx plus c, where of course a is not 0, because if a were 0 then it would be a linear function, right? You should have a quadratic polynomial over here like we have here. right? 1x squared plus 0x minus 3. Right? But yeah, the graph of any of these quadratic functions will form a parabola, right? Something called a parabola. Now the parabola can look like we have there, where it's opening up, or it'll be flipped, or it can open down. Now, if the function were a function of y, then the parabola could open right or left, but we're not going to be focusing on any of those just yet in this video. Just parabolas that open up or down. Right, so this one, this one opens up, right, as a cup holding water, if you want to think about it that way. Okay, great. So, and again, I'm going to show you a little better picture on the Desmos site. So remember, I've shown this to you in other videos if you've been watching. This is a free online graphing calculator at a site called desmos.com, desmos.com. And yeah, I'll just enter the function as it was given to us, f of x equals x to the second power minus 3. And you see our red graph there pretty well matches the green graph I drew by hand. Right, and there's your x-intercepts, y-intercept. Now we plotted this point, right, 0, -3. And again, you can make a table, right? And you see these points popping up are like the points I plotted in my hand table, right? -2, 1, -1, -2, 0, -3, 1, -2, 2, 2, 1. And I can just keep adding to this, input 3, output 6, right? Input -3, output 6, right? And those points show up on the graph, right, like I did in my hand drawing. So there's, there's -3, 6, there's 3, 6, there's 2, 1, there's -2, 1, -1, -2, 1, -2. Come on, show up. Yeah, 0, -3. I don't know why that's not showing up, but yeah. So like a much cleaner looking, obviously, because the grid is nice. It's on a computer. It's better than my hand drawing, but still my hand drawing looks pretty close. So I feel like I did a good job. And then again, you zoom out, you scroll out, and you can move it around like any map. Right? Hit the home button, go back to the usual -10 to 10, x-axis, whatever. Okay, so let me get rid of this stuff, go back. Oh, I'll just keep that up. Alright, so that was example 1, right? The graphing, simple stuff. Alright, so the next exercise is the same thing. I'm asked to just graph by plotting points. So example 2, exercise 232 from the text, we have f of x equals, -1 times x squared minus 1. So again, I'll make a little table. It's input x, output f of x. And over here, I'll do my best to make a reasonable hand drawing of my graph, right? X and y axis, or x axis and f axis, because the function's called f, the output's called f of x. And I'll plug in the same 7 values, right? You don't have to use these 7 every time. I just like doing it for these quadratic functions, right? -3, -2, -1, 0, 1, 2, and 3. And we're going to see in a later video how to much more quickly and easily graph quadratic functions. For right now, I'm just doing it kind of the lawn way. Alright, if I were to plug in -3, well, -3 squared is 9, but then you got the -1 here, so -9 minus 1 is -10. Alright, so input -3, output -10. I'll plot that point. Input -3 on the x, output -10 on the y, and just eyeballing it here. Again, this is a hand drawing. Probably not going to be the greatest looking thing ever. If I input -2 for x, -2 squared is 4, but then you got the minus here, -4, -1, -5. Right, so input -2, output -5. And I'll plot that point. -2, -5, that's this point here. Okay. Now again, that's not enough, right? This is a squared, this is a y equals some quadratic polynomial. It's a quadratic function, so it's not going to be a straight line, right? Don't just stop after 2 points. Plug in -1 for x. -1 squared is 1, but then you get the minus here, so -1, -1, that's -2, right? -2. So input -1, output -2. Right there. Input 0. 0 squared is 0. The opposite of 0 is still 0, and then 0 minus 1 is -1. So input 0, output -1. So input 0, output -1. That's this point here on the y-axis. And now we can see it start turning. Right? This is definitely, again, this is going to be another parabola shape. And it looks like it's going to be a parabola that's opening downward, right? Not opening up like the last example. Alright, input 1, output -2 again. You'd have -1 minus 1. So input 1, output -2. So that's actually on my -2 here. Sorry about that. That point. Input 2, you'd have -4 minus 1, -5 again. So input 2, output -5. So around here. And then input 3, you'd have -9, minus 1 is -10 again. Output -10. And again, just eyeballing it. So yeah, it looks like this kind of a graph would be formed. Connecting the dots here. And again, please don't make it pointy. Make it more curvy at the turn. Right. And it looks as though if I were to go 4, 5, 6, 7, the outputs would decrease. And so a little arrow going down forever. Same thing over here. If I put in -4, -5, -6 for x, the outputs would keep getting small, bigger negative, smaller and smaller. All right, there we go. Now, look at these two examples, and I'll put this up on the Desmos site again. But look at this first example, right? Going back to number 1. See how the parabola was opening up? Right, again, like a smile. Right? This parabola was opening up. Look at the equation. Y equals, or f of x equals, 1x squared minus 3. The lead coefficient, the coefficient on x squared, is positive. And there's actually a connection between these two. If the lead coefficient is positive for your quadratic function, your quadratic polynomial, the parabola you draw will be opening up. And I'll write all this on a separate page as well. And then you look at this second example. So this parabola here is opening down. Right, a frowny face. Okay. And then look at the quadratic polynomial. Right, look at the quadratic function. See the lead coefficient, the coefficient on the quadratic term, is negative. And there is another, again, another connection between these. And you'll see, and I'll write this on a separate page, but if the lead coefficient is negative for these quadratic functions, the parabola you end up drawing, the graph of that function will be a parabola opening down. Right? So yeah, so I'll actually write that on a separate piece of paper, because that's going to be our next exercises. Right? Well, not a separate one, I'll just write it on this one. Oh yeah, and let me show you the function on the website. Alright, so that function was f of x, or y equals, negative 1 times x squared, and then minus 1. And you see our parabola opening down here, just like I had in my drawing. I like to, just to point out some points, let's make a table, convert to table here. And then all these points pop up. You see negative 2, negative 5 right there. Positive 2, negative 5, right? 0, negative 1, 1, negative 2, and negative 1, negative 2, right, on this table. And you could add more. You could always add more. We said 3, negative 10. Right, there's 3, negative 10. We plugged in negative 3 as well, right? Also got negative 10, right? There's negative 3, negative 10. And you could plug in other numbers, right? Plug in 1/2. And you see negative 1.25. See this point show up here. Right? You don't have to plug in integers. But they should all form, after plotting all of them, they should all fall along this parabolic shape, opening down. Okay, great. Alright, so now next question. We're not asked to graph anymore. I'll still show you the graph on the Desmos site. But all we're asked to do in exercise 3, number 234 in the text and number 236, we're simply asked to determine if the parabola opens up, so like a smiley face, or opens down like a frowny face. Right? And it's very simple. Right? So just here's all you have to remember. For quadratic functions in standard form or general form, depending on what text you're reading. So I'll say for quadratic functions, y equals, so let's say y equals, it could be f of x, g of x, h of x, y, whatever. Y equals ax squared plus bx plus c, right? Y equals some quadratic polynomial in standard form. If a, right, if a, the lead coefficient, the coefficient of the quadratic term, if a is positive, then the parabola opens up. Right, it'll be a smiley. Have a positive attitude. It's a silly way to think of it, but if it helps you remember, great. If a is negative, right, if a is less than 0, if the lead coefficient is negative, then the parabola opens down. And it's that simple to tell. Right? A frowny face has a negative attitude. And this is all you need to remember for these exercises. So simple enough. Part A, we have f of x equals 4x squared plus x minus 4. See that the lead coefficient, right, the coefficient of the x squared term, the highest powered term, is positive, meaning that the parabola will open up. And that is all we need to say. That is all they're asking us to do. Determine if the parabola opens up or down. And let's take a look. All right, I'm going to put that function into the Desmos site. We have f of x equals 4x squared plus x minus 4. And look at this, right? The parabola, going back to the home area, right? Definitely a parabola opening up, right? It's a cup holding water, a smiley face, whatever you want to think of it as. And that's all. That is all we're asked to do for right now. We'll talk about graphing in more detail in a future video. Okay, part B. F of x equals negative 9x squared minus 24x minus 16. These lower powered terms don't matter when you're talking about, if the parabola opens up or down or not. All that matters is the lead coefficient, the coefficient on x squared. The lead coefficient here is negative, right? It's negative 9. So that leads me to believe, it tells me, not believe, but actually know, that this parabola will open down. It opens down, a frowny face, a cup pouring water out, a cup turned over. And that's all. All right, let me show you. All right, I will enter this function into my Desmos calculator here. F of x equals negative 9 times x squared. And you already see a parabola opening down right now, right? That black graph that just showed up. Minus 24x minus 16. All right, and here we go. All right, see, this is definitely a parabola opening downward. A frowny face, a cup dumping water, however you want to think of it. Okay, wonderful. All right, and then I've got just one more page. And all we're asked to do again for example 4, exercise 236, is simply state whether or not the parabola opens up or down. We're not asked to actually graph it just yet. So look, positive lead coefficient, f of x equals 1x squared plus 3x minus 4. Positive lead coefficient, this is going to open up. That's it. That's all I'm doing. Now I'll show you that it opens up. We'll look at a graph. F of x equals x squared plus 3x minus 4. And you see definitely this red graph that just showed up, a parabola, opening upward. Very, very easy to determine. And then part B, f of x equals negative 4x squared minus 12x minus 9. Negative lead coefficient, right? Negative lead coefficient in this ax squared plus bx plus c. So I can tell you right away that this will be a parabola that opens down, like that. Right. See, smiley face, frowny face, okay. And once again, I'll just show you, right? Nope, not that one. Hello. You saw me. You saw my face for a second there. All right. I'll show you by going to the Desmos site. All right. So we have f of x equals negative 4 times x squared minus 12x minus 9. And there you go. Definitely a parabola opening downward. Great. All right, that does it for those exercises. And I'm hoping that watching me, go through these 4 exercises here help you when you're asked to, recognize the graph of a quadratic function, graph by plotting points, determine if it opens up or down, right? When you're asked to do that on your own, I'm hoping these help you out a bit. And thank you very much for watching.